This is 6.4 part 4. So we had finished off this question over here where we were trying to find how long the ball was over 10 seconds or above 10 meters. And so we set up our work like this. It was a bit sloppy, but just to show you how you would carry out in proper order, you would do your sketch first, set your height to what the question was asking, so above 10 meters over here, and then plug that into the height part of the equation to get an equation where it equals 0 in the end by sending the constants to the other side. And that way you can solve for t using your quadratic formula, and then you'll get two answers here. And so these are not your final answers. You need to interpret this. We're asking you how long it was in the air for above 10 meters. So it's from 0.53 seconds to 3.67 seconds. So you take the difference to get the actual amount of time it was in the air for that height. And that was about 3.14 seconds, and you write your therefore statement. So I've numbered the steps in the order that you should carry them out. When you have more room, you have to make sure you're nice and organized and nice and clear. So what we're going to do is we're going to do this last example together here, where we have a rectangular park, and we're going to solve the problem by starting with a sketch and then interpreting the problem. So a rectangular park measures 100 meters by 60 meters. So let's draw that rectangular park in there. So our first step is our sketch, of course. We'll make it a rectangular park. And we know it's 100 meters length by 60 meters width. A path of constant width is to be paved around the perimeter. The mayor thinks the park would look best if the path has the same area as the park. How wide should the path be? So we're going to draw the path around here. So we're making a path around the perimeter. And we want to make it the same width all the way around. I didn't do a good drawing there. I should have been a bit better with my scale. But the idea is that it's the same width all the way around. So this would be the same as this, would be the same as this, would be the same as this, would be the same as this. And again, my drawing is just a little bit sloppy there, just went off there, but it should be the same width all the way around. And so what we want to do is we want to make sure that this area here, this whole area of the pavement, is the same area as the park itself. And so there's a couple things that we know. First of all, we do know the surface area of the park. We know that the park is rectangular, and so the area is going to be area of park is equal to the length times the width of the park. So area of park is equal to 100 times 60. So that means the area of the park is 6,000 meters squared. And we do know how to write an expression for the area of the this pavement area. In reality, the area of this pavement area is actually going to be the area of this part here plus the area of this part here plus the area of this part here plus the area of this part over here. How do we find all that? Well, first of all, we can find the length of this pavement part by knowing this is 100. This missing part here has to be x, and so does this, because it's the same width all the way throughout. So we know the length of our park. So I'm going to write down some information here. Step 3. The length of our park is equal to 100 plus the x over here and the x over here, which is 2x. 100 plus 2x. And we also know the width of our park, if we wanted it. We don't really need it right now, but we know the length of our park is that. Another thing we know is that this part here, we do know its measurements, would be 60 over here and x over here. So we could actually figure out the area of this part and this part, and then simply multiply everything by 2 to get the total area of this area here. So let me show you what I mean by that. This part here must be x, because it's the same width all the way around. So the area of the pavement, not park, is going to be equal to 2 times this area, because there's 2 chunks of this, up here and over here. So 2 times the length, which is 100 plus 2x times x, because that's the x value here. And again, it's 2 times that because it's this and this, plus the little areas over here, and that's going to be 60 times x. But don't forget there's 2 of those, so it's going to be 2 times 60 times x. And so we'll just clean this up a bit. We'll get area of pavement is equal to 2 times 100x plus 2x squared plus 2 times 60 times x is 120x. So that means the area of the pavement is going to be equal to 200x plus 2x squared plus 120x. And sorry, I should have said 4x squared, because it's 2 times 2 there, so 4x squared. And so that's going to be area of pavement is going to be 4x squared plus 320x. Plus 320x. That would be a general equation for the area of the pavement. But now what we know is that we want the area of the pavement to be equal to the area of the park. So we can make a better equation. We can say that the area of the pavement, which is 6x squared plus 320x, is going to be equal to the area of the park, which is 6,000. And so our goal is to find how wide the park should be. We want to find this x value. So what we can do is we can rewrite this as 4x squared plus 320x. Send this 6,000 to the other side by doing inverse operations, and you get negative 6,000. And so that's going to be 0. What we can do is we can factor, or we can solve, I should say. We can solve for x. You can try factoring, but I'd like you to practice with the quadratic formula. And we're not even sure if this is factorable. You'd have to try it out using one of the methods we learned earlier. So if you use your quadratic formula, you would have x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. You can plug your numbers in, so x, and always find your a, b, and c first. So our b is 320, so negative 320 plus or minus square root of 320 squared minus 4 times negative 6,000, so 4 times 4 times negative 6,000 over 2a, so 2 times 4 there. And then we can clean this up a little bit, so let's clean that up and we get x is equal to negative 320 plus or minus, let's go see what all this equals to, 320 squared. And I'm just doing everything in the brackets there right now in my calculator, minus 4 times negative 6,000. So I get the square root of 198,400 over 8. And now what I can do is I can go and figure out the plus and minus pathways. So I'll do the plus pathway this way, the minus pathway this way. So I get x is equal to negative 320 plus square root of 198,400 divided by 8. So that would be x is equal to, so let's try that out, see what we get. We get 15.677, so 15.68 roughly. Let's see what the other answer is. We can get x is equal to negative 320 minus the square root of 198,400 over 8. And we should get x is equal to, so let's try that again. So we get square root of 198,400. Then we do plus minus 320 divided by 8. We get, if you plug that in your calculator, negative 95.68. Now we're looking for a width. This one here probably does not make sense because it's a negative value in this case. So the width we're going to go with is this one here. So we get that x is equal to 15.68. So that means that, therefore, the width must be 15.68 meters. And so all these problems have been very similar to each other. It's just a matter of solving for what you're looking for. Again, the first step is interpreting that problem and drawing it out properly, then writing out equations that you may know. There's different methods that you could have used here. You might have written a different expression depending on how you chose to calculate the area, but the end result would have been the same answer of x is equal to 15.68. Be sure to use the skills that we're teaching you in this chapter. Don't try to go for trial and error and plugging random numbers in, because it's not the skills we're testing and we're assessing. I want to see that you know how to use these equations, you know how to set these up, and you know how to use the quadratic formula as well. So that was lesson 6.4, part 4. Please make sure you watch the videos, do all the examples, remember how to use that formula and how to interpret questions as you read them, especially with a sketch.